Hello, everybody. My name's Matt Slaughton. I'm a principal solutions architect here at Veeam, focused on our Kasten product. And I'm joined by my esteemed colleague, Mr. Michael Cade. Would you like to introduce yourself?
Yeah, hey everyone. I'm Michael Cade. I'm a field CTO here, and for the last 4 or 5 years, I've been delving into the world of Kubernetes and namely Veeam Kasten for Kubernetes as well. So excited to get into it.
Absolutely. So in this presentation, we're going to be covering de-risking modern virtualization with Veeam Kasten and Red Hat OpenShift. We're going to keep it relatively loose. So Michael and myself will definitely be kind of conversational here. Hopefully you guys can learn something a little bit about obviously Kasten, OpenShift, and why we're talking about modern virtualization to begin with. So with that, let's go ahead and dive in, Michael. All right, so here's my fun AI generated image of a ship in a squall. I love a ship in a squall. But why are we here today? Why are we having this conversation? Obviously, there's some headwinds, if you will, to keep along the sailing terms here in the industry, right? So kind of everything else aside, we see a general push towards application modernization. And for good reason, right? So application modernization, what do I mean by that? I mean moving from traditional kind of three-tier architecture or even just virtual infrastructure to actually more of an app-centric infrastructure or app-centric model, like containerization, like microservices. So there's kind of this undercurrent, I'd say, Michael, would you say the last like 10, 15, I'd say 10-ish years is kind of when we started seeing this come up in 2014, 2015, and it's only grown. Would you agree?
Yeah. Well, if we look at like Kubernetes in general, that is the orchestrator of containers, is around coming up 12 years old. So it's been around a while. Before that, we had the containerization like era around Docker and Docker containers that started that journey. And then Kubernetes was the orchestrator of that. But yeah, I think a common trend should be to think about how we could re-architecture some of those applications to work better with scale and kind of decouple them so that they can work better in that microservice type environment.
Absolutely. Yes. Yeah. So, and again, yeah, the benefits there and kind of lead to the next point, this increase in velocity, right? So what does that afford us when we move away from kind of a traditional three-tier, and going back to my old, back in school where we talk about model view controller or, you got your web server, application server, database server, it's still very kind of monolithic, right? So if we want to, push updates to our application, whether it's customer facing, internal, what have you, kind of in that traditional model, we have to go through a lot of regressive testing. It's kind of one application. So if we modify part of it, we need to make sure the other parts still work. So it's somewhat inflexible. Whereas when we move to kind of containerization and this microservice architecture, we've introduced kind of this greater portability and granularity in our application. So we can be much faster when it comes to innovating, to updating, to adding features and capabilities. So that kind of, these first 2 points kind of align in terms of, why would we go microservices? It affords us greater velocity and potentially a competitive advantage over our competitors and be able to innovate more quickly. Anything to add, Michael, before we go to the big wave in the sea?
Yeah, just that like there'll be a lot of the audience that are potentially looking at this or think that they're well like miles away from getting close to microservices. One thing I will say is that a lot of the commercial off-the-shelf software is starting to be packaged in that microservice type architecture. So you'll download it or you'll install it using Helm. We're not going to get into all of the technology bits of how you deploy that, but they're packaging it in that containerized image type factory. So it's coming to those that I think there's a misconception that Kubernetes is just there for developers. If you're developing software, develop it for microservices, but that isn't the case always for all customers that use majority of commercial off-the-shelf software. That's also coming to our industry, and I guess that again leads into the next point there, Matt, around some of the other windy and wavy stuff to keep to your thread.
Let's keep my metaphor going. Yeah, we've got a was it a rogue coming now with the industry upheaval. So, the elephant in the room a little bit is recent acquisitions within the industry, right? So we've seen, I guess we've seen a large acquisition for a key player in the virtualization space that has really elevated costs for a lot of organizations that, for the last, we'll say almost 20 years, have kind of standardized in a virtual infrastructure environment. Suddenly their bills are now 3 to 10 times or even sometimes more than that in specific cases. So, we had these kind of first 2 points of, okay, application modernization, we see the benefits, velocity, but now we also have a bit more of a push from a cost perspective where operational costs are suddenly significantly elevated. All the while, we want to make sure we're not forgetting our modernization. And to your point, Michael, as more commercial off-the-shelf offerings are containerized or available within Kubernetes, that we're not neglecting that as we move that way. So certainly a factor there. And I know, Michael, I'm sure you talk about this all day, every day with many customers. So I'll let you add your color there as well.
Yeah, so I've been using another analogy around the hypervisor Hunger Games, and where we're going to talk about VMs on Kubernetes and that movement. There's obviously, and hopefully you're seeing that from the other sessions from the event. You're seeing like Veeam's strategy across multiple hypervisors is being able to support our customers wherever they go to choose to run their workloads. That doesn't mean that we're moving away from development of the big like vSphere environments. In fact, I would say that we're actually doubling down and doing more there. But equally, for other hypervisors that are being evaluated and looked at, including Red Hat OpenShift virtualization and others, we're constantly looking at how we can improve our customers' experience and their data resilience on those platforms. But yeah, the hypervisor Hunger Games has been my talk track to that.
For sure. Yeah, definitely an interesting time, in the industry, and it's exciting. Yeah, there's a lot of choice, but there's also a lot of choice. So definitely can make it challenging sometimes, which I guess again leads to that next point here is upskilling existing resources. So this one actually for me personally kind of very much reigns true, because for me, when I first was introduced to Kubernetes, it was almost a bad word because I come from that virtualization world. I come from understanding infrastructure, storage, network. And to your point earlier, Michael, I kind of saw Kubernetes as like, oh, that's a science experiment on the side for developers. I don't need to know that until I really got hands-on with it. And honestly, I was clawed into it in a previous organization. Essentially, I was made responsible for a Kubernetes native app. So I had to very quickly learn kind of how this was different from traditional infrastructure. So I had to upskill, and it was a bit of a steep hill to climb initially. However, once you kind of start seeing the top, I kind of started seeing how things fit together and how beautiful Kubernetes can be, at the risk of waxing poetic. But yeah, I think certainly organizations need to be aware, though, that as they potentially replatform, as we look at modern architecture, we need to make sure that we're not leaving our key ops people, our key engineers kind of behind. There is a bit of a learning curve here, so we want to make sure that we choose platforms or solutions that can kind of ease that transition as much as possible.
Yeah, exactly. I would only add to that, Matt, around Kubernetes is just another platform as well, right? So we've known our hypervisors from a storage, compute, and networking stack. Kubernetes doesn't bring in any additional physical hardware or requirements. It's still just compute, storage, and networking. We just tend to see a little bit more a different terminology is being used in the Kubernetes world. And hopefully me and Matt can kind of distill some of that as we go through. But a virtual machine is a virtual machine at the end of the day. And yeah, we'll get into that as we go through.
Awesome. Yeah, and then our last point, which I'm going to use to kind of quickly jump to the next slide, is all the while, we still have this, and I still, since the last kind of 15 years, the cloud era, this notion of having hybrid and multi-cloud. So a lot of organizations, early in the cloud era, moved everything into the cloud. I think we're starting to see a little bit more, not full repatriation, that's always a tough word, but we are seeing a bit more hybridized deployments, and for good reason, right? So cost is a big factor, flexibility is a factor, performance. So we need to make sure that when we choose a platform, we have this kind of in mind as well, that we don't lock ourselves into a particular cloud or into a particular footprint, and we have that flexibility to, whether it's cost optimized, performance optimized, what have you. So I'm going to hop on over here to this slide. And we'll go through this quickly, but I like to kind of lay the land here. How did we get here? Where did we come from? We've kind of alluded to this in the previous slides. That's why I'm going to try not to belabor it too much here. But over time, as we've kind of progressed within infrastructure and IT and just our industry, we started, for the longest time, just having physical systems. Going back to that model view controller, you could have a physical web server, a physical application server, a physical database server. Sometimes we collapse that all into one server, but you get the idea. It's not very flexible, and we often have resources that we're not utilizing well or efficiently, because oftentimes we have to build our systems. It's the peak load problem, right? If you have a power company, is a great example. Is power companies have to build infrastructure to support peak demand, so the coldest day of the year to heat or the hottest day of the year to cool. They have to have the wires and the infrastructure transformers to be able to support that. Similarly, in IT infrastructure, it's the same. We need to make sure that our application servers have the resources they need during peak demand. So let's say if we're a retailer, leading into the holiday season, you make sure that we can accommodate that. But as a result, we end up having to overbuild our systems quite a bit. And for a long time, we just had to kind of live with it. And, for guys that like to tinker like Kate and myself, we love hardware and physical things, but it can get a little unruly sometimes, especially when you start losing a disk or, a network card goes down or something like that. If you've got a bunch of different physical servers, maybe different versions, different manufacturers, it can get a bit messy. So enter kind of the late 90s, we'll say really more early 2000s is really where we saw virtualization take off, right? So this is, and I guess nod to you, Kate, I leaning on my old Australian, putting the S in virtualization here. I lived in Australia for a couple of years. Obviously my accent is not very Australian. However, nonetheless, virtualization was a game changer for the industry, right? So that issue of peak load kind of sizing and infrastructure was significantly reduced with virtualization, where we could leverage this excess compute, storage, memory for other workloads, and also, all the while affording greater flexibility for like maintenance and downtime, be able to move these virtual machines across different physical hosts, just made it much more flexible, much more cost effective, and really, we saw greater density. Kind of this is the first kind of foray into kind of increasing that density. So I'll pause there. Anything you want to add before we get to the cloud era?
Yeah, I think and maybe everyone in the audience has experienced this timeline, this linear timeline that is, and I think the important thing to note is none of these have gone away. They're all evolving. I've spoken to many customers over the last year about physical systems. I think one thing to mention about the virtualization space is now we went from jamming everything into those physical servers, sometimes putting too much onto those in terms of applications and wedging everything into that physical footprint. Virtualization came along and we went, we can have a virtual machine for absolutely everything. And we then had this VM sprawl, and then along came public cloud, which gave us the ability to run virtual machines in the public cloud. But equally, and the graphic doesn't do it justice, is that now we can have PaaS-based services, so platform as a service, things like database as a service that are still running on a server per se, but you just don't have access to that. And we had that cloud scale to be able to run our workloads in a more elastic way in terms of being able to spin things up, spin things down, and move it around wherever it needed to go. And then I'll let Matt get into the end of the line here.
For sure. Yeah. Well, and it's a great point too, to kind of carry forward the sprawl. Really, cloud's incredible. Like you said, you introduced a lot of things like managed services or platform as a service, but it really just let us kind of sprawl away from our house into our neighbor's house, or, in this case, our neighbor's Amazon. So it didn't really fix kind of that sprawl issue per se. It just kind of alleviated the pressure a little bit, and still does today, right? So, I don't want to discount the benefit of cloud, and, sprawl is not always a bad thing. Obviously, it's kind of somewhat of a negative term, but, it's a great example. Going back to that retailer example, is maybe during times of high demand, we spin up a virtual machine in the public cloud during the holiday season. We obviously kind of can put that under OpEx. We don't have to make a capital investment, but then once the holiday season's done, the returns have happened, because I know January is also very busy for retailers. We can then scale back maybe just to our data center. So definitely a lot of benefits there. Although to Michael's earlier point too, we need to be mindful that we're not just spreading our infrastructure far and wide for just the fun of it. So
Yeah.
kind of go ahead, Mike.
So I was just going to say about the cloud not being a charity, right? Whatever you do up there is going to cost you some money.
Yeah, I'm sure you have too. I remember years ago, on a whim, kind of spun up an AWS account, plumbed it to my local lab, and kind of forgot about it. Then I got a bill for like $900, and yeah, that was an awakening on a personal level. It's like, oh, maybe we should optimize our cloud costs within the Slotin household. So. But so yeah, moving to the right, then we introduced containers, right? So we alluded to this before, and I won't try not to belabor it too much, but containers afforded kind of the smaller footprint. So we don't need the entire operating system, all of the updates, all of the things that are required to run a full machine. We can just now include just the key components, the core kernel, the specific binaries that we need to run our application, and therefore have a much smaller footprint. And also more flexibility, right? These container images are immutable, so essentially we can bake them, and then if provision them, if it dies, we just spin it back up, and we're happy and have our application back up and online. And this was great for a home labber, I'll say. If just the container, if we're just talking about container runtime like a Docker or a Podman, it's a fantastic technology. I use it in my personal home lab today. However, if you're an enterprise, you probably want some sort of orchestration, right? We're not going to try to manage Docker Compose. There was early Docker Swarm as well. It kind of meets the burden, but really, if we're an enterprise, we want to be able to scale dynamically. We want to be able to recognize times of high demand and automatically have containers or even physical nodes provisioned on our behalf, and then scale down as well, which is kind of where we've entered into the Kubernetes world. And so as Michael alluded, it's been almost, I guess, 12, 13 years. Kubernetes originally open source project released by Google. The project's flourished. There's a ton of different distributions. We're going to focus on Red Hat's OpenShift today. But essentially, that is the orchestration component of containers. So Docker is still there. Docker runtime is still there, or Cryo if you're in the Red Hat space. But at its core, we're now adding an orchestration layer around those container images that makes it much more enterprise ready. So that was great, and is great. We see a lot of organizations today that have a mixed environment. They may have a significant virtualization footprint, but also significant containerized footprint. But the problem with that is we're dealing with kind of two different platforms, as Michael said before. They're both kind of storage, compute, network, just kind of in different flavors. Sometimes, for the longest time, we'd often see virtualized versions of Kubernetes, right? So our worker nodes are running maybe on top of a hypervisor. And that works relatively well, but talk about kind of redundancy and not great use of resources, in this case, human capital. I hate that term, people. We suddenly kind of see might be a benefit to collapsing the stack here, where we can essentially leverage the same platform for both our virtualization and containerized workloads. And that way we're essentially future-proofed, even if today we just want to move VMs from our legacy hypervisor to a more modern platform. So I'll pause there, Michael. I'm sure you've got something to add there as well.
Yeah, I think like how this is diagrammed in a linear history of time is we've seen customers that will take bare metal and use them as your Kubernetes nodes. Equally, though, we see a lot of Kubernetes running as virtual machines, as Matt just said. Now where we're going to go for the rest of the talk is around that containers or Kubernetes plus that KubeVirt, which is the ability to run that virtualization alongside your containerized workload. So now we just need one portal to go and manage both our microservices and microservices that might be very that need that virtual machine footprint. Maybe it's a database server that is much harder to lift and shift into or modernize into a container. So now I can keep that database server as a virtual machine, but now it's on that same platform. Because as soon as you have to go from one storage compute networking stack to another, now we're beholden to the latency and the physics between that. If you're on the same box and you're using the same storage compute and networking, now we can take advantage of speed and everything within that. So I know that's where we're heading as another option. And I don't know how far Matt's going to get into the KubeVirt weeds, but ultimately we're using that virtualization layer that we talked about earlier that allows us to expose the ability to run virtual machines. It's a tried, tested virtualization layer within Kubernetes.
Absolutely. Yep. And we will dive in a little bit to the architecture there. Conscious of time though. So I'll try to move faster. I'm full of hot wind, as Michael knows. So I'll try to minimize that. Or I guess a sea squall. I don't know. I'm losing my metaphor now. Anyways, so what is KubeVirt? And Michael alluded to this. It's essentially a commercialized offering around virtualization within a Kubernetes platform. I do want to kind of draw the distinction, and it's arguably important, but also not that important. But it is not technically a Type 1 hypervisor. It's built on a lot of technologies that are used in kind of KVM, which is a traditional Type 1 hypervisor, but it's essentially just packaged in a different way. So to Michael's point, it is a tried and true technology. KVM's been around for ages. I know Red Hat had their commercial offering Rev. I think it was like around 2008, I think is when they released that. So KubeVirt is essentially built on the foundation of KVM and KEMU and libvirt and all those technologies, but it's essentially packaged in a different way, where essentially the container provides the kind of conduit down to the physical host. But we're, in a way, you can say we're running VMs in containers. It's a little more nuanced, but high level. I think it's safe to say that. But as a result, because it's KubeVirt, we can kind of treat containers and VMs both as first-class citizens. So we can orchestrate both these resources across nodes. We can spin them up. We can, scale down, what have you. So it adds a lot more flexibility using that single platform with our constraint of physics, right? We've got our only, so much disk, so much network, so much compute. We're able to distribute that appropriately across our different workloads, whether they're VMs or containerized workloads. Anything to add there, Michael, before we move on?
No, I think you nailed it, mate. I think, exactly that. This is that layer that treats all virtual machines the same as what your containerized workload looks like.
Awesome. All right. So to briefly kind of dive in a little bit what this looks like, we've discussed this a little bit, but I want to get kind of a diagram here. We've got our infrastructure-centric approach using our kind of more traditional virtualization-focused approach to a platform, right? So on the left, we've got a typical kind of Type 1 hypervisor. You've got a physical host underneath, the hypervisor is installed on it. You then maybe have a number of VMs that are running on that hypervisor. And then if we're running Kubernetes, maybe those Kubernetes nodes are actually VMs that are running on our hypervisor. So, it's a bit of a taller stack, as you can see here, like literally you've got virtualization and then you've got Kubernetes on top of it. So you've got different kind of administrators working on different parts of the platform. We're moving to the right. We're essentially collapsing the stack. We're using a common platform. We've got, still a physical host, but now our node is essentially the physical host, and then our app and VM can live side by side as besties, and we can orchestrate them together. So essentially collapsing the stack, better resource utilization, and also from an operations perspective, we're not having to manage two completely independent platforms.
Yeah, the only thing I'd add there, to that last slide, Matt, is I see a lot of companies and customers go down that virtual machine road first to spin up 3 Ubuntu boxes, RHEL boxes, and that forms your Kubernetes cluster. But then a different team, an infrastructure team, are looking after the underpinning hypervisors. They get the app teams, the DevOps teams get shouted at because they're using a lot of the resources in that Kubernetes cluster, because you're layering. If anyone's played around with nested hypervisors, you're starting to get into the world of nesting a lot of this stuff when it comes to Kubernetes on virtual machines. Is it a thing? Yes, people are absolutely running production workloads there. What this app-centric model enables us to do is be a little bit more controlled, and we're not shouting and fighting different teams around like who has all the resources to play with.
Absolutely. And there's a point here that I forgot to raise as well, is obviously with this kind of more optimized or streamlined stack, we're not doubling our licensing costs anymore. So we're not having to pay for our Type 1 support and licensing, and then also maybe our Kubernetes support and licensing. We can just have a single platform, essentially eliminating the redundant licensing, if you will. Another fun AI image. I was actually very impressed when I was able to generate this one. I would totally eat that. But anyway, some key considerations: modernization onto a new platform. So to beat a dead horse, but also move kind of quickly. Michael had touched upon this earlier. OpenShift, much like maybe VMware vSphere or another type 1 hypervisor, at the end of the day is a platform. So we're still bound by the laws of physics. We still have storage, network, compute. It just looks at these kind of resources through the lens of more application centricity. So we're looking at these resources as I hate to say it, but almost more of a commoditized resource where it's the infrastructure is kind of taken as is, and then we're able to provision our workloads kind of dynamically in scale on top of that infrastructure. But at the end of the day, it's not magic, I guess, is the key message there. As a result, a lot of fundamental concepts apply to both, right? So again, we're bound by the laws of physics, but because we're looking at things through a new paradigm, through a new lens, it's not always apples to apples when we compare maybe a type 1 hypervisor with KubeVirt. There's a lot of things that we need to consider, like what existing operations can we still use versus what do we need to modify for this new platform, maybe tools as well. Hint, maybe our backup tool needs to be a little bit different in the Kubernetes world than maybe traditional infrastructure. So there is a bit of kind of recognizing that, yes, this is a new paradigm. There are some things that apply, but there's some other things that we have either need to kind of rejig or have kind of usurped the traditional approach.
So my talk track here, Matt, is remember when Veeam came to market in protecting virtual machines on VMware, is a lot of the traditional competitors that we had at the time, they would just say, oh, throw an agent on that virtual machine and start protecting it that way. Veeam came along and went, no, there's a much better way. We're going to go in at the vSphere API layer or the Hyper-V layer, and we're going to instruct the backup to happen there versus having to have an agent that needs managing. I know we're going to get into the Veeam Kasten perspective of backup, but that's almost what Kasten has done from a Kubernetes point of view. It approached things differently when it comes to Kubernetes because it needed to hit that native API to be able to take that protection to that next level versus using an infrastructure-centric tool like a Veeam backup and replication to be able to protect those virtual machines.
Absolutely. Yep. Good point. And yes, cut from the same cloth as well of, yes, focusing on what is the best approach given this new paradigm. I keep on using that word, but it's a fun one to say. Essentially, we want to make sure we're not trying to square peg round hole when we're looking at data protection for this new approach. All to say, VMs and OpenShift and even non-VMs, I'll say, containerized workloads still need data protection. So we don't dive into it too much in this presentation, but I know, Michael, I'm sure you've heard it. I've definitely heard it at a number of KubeCons. Somebody comes to the booth and says, I'm completely stateless. Why do I need a data protection solution for my Kubernetes apps? Well, my first question is, are you considering KubeVirt? Because in itself, a virtual machine is stateful. And if you're not, that state still lives somewhere, whether it's on the Kubernetes cluster or outside. You still need a data protection solution that can protect that data as well as the Kubernetes aspect of it. You can certainly, home roll your own, and I'll get off my soapbox in a second, but who has time for that, right? Most of us are not dedicated Kubernetes data protection engineers, right? We typically are more platform engineers, and so really we want to leverage the best possible enterprise tool for that data protection rather than having to try to roll our own and maintain our own custom bespoke offering.
So added to that common conversation, yeah, we're stateless. And then my question is, how many PVCs do you have in your cluster or persistent volume claims? And generally that gets a conversation going, because if you've got a PVC, a persistent volume claim, it means you're storing something that you want to be persistent. And that might be configuration files, it might be logs, but you start to ask the question, how important is that data? It might not be a MongoDB database, it might not be Postgres, but maybe if you're having to persist something, it probably is important and probably needs protecting. In general, like a lot of the virtual machine disks are PVCs by all accounts, to Matt's point.
Absolutely. All right, so yeah, this is kind of that new approach. Then we're talking about that traditional infrastructure-centric approach versus this modern application-centric approach. So we've touched upon a lot of this, so just somewhat of this review, but using traditional backup tools, whether it's Veeam backup and replication or a competing tool, we really looked at kind of the virtual machine as the atomic unit because our application lived on the virtual machine. If we backed up the virtual machine, we backed up our application. And that mostly works except for kind of data workloads. That can start getting somewhat complicated, especially if we have a lot of read and write operations happening at once. Taking a VM snapshot may not be sufficient. Obviously, VBR has done a fantastic job of having a catalog now for kind of this application or database-centric ability or approach for these database workloads. But that doesn't necessarily work as well when we start looking at microservices or looking at an application-centric approach that is Kubernetes and containerization. We're really, we've somewhat collapsed the stack almost back to that earlier slide where we're looking at the application as the atomic unit, not the VM or its infrastructure. So really, we're looking to protect the application. That's a key distinction that I like to draw with a lot of customers is that are looking at moving to Kubernetes or modernizing, is we're not actually backing up the Kubernetes cluster. We're backing up the Kubernetes applications on the cluster. We treat the cluster as like kind of commoditized infrastructure or resources, which is a little bit of a different approach than the maybe traditional backup solutions. Also, worth mentioning that, it's important. I like to draw the parallel. If you're in a vSphere environment, we'll pick on VMware a little bit, backing up the VMware database, the vCenter database. Are you backing up your infrastructure if you back that up? No. So much like the same in Kubernetes, if you're backing up etcd, which is Kubernetes kind of data plane or orchestration database, you're also not backing up your cluster. So really, we want to focus on the actual workloads running. And that's kind of the parallel I try to draw between an application-centric versus a virtualization-centric approach. So just high-level reminders, just this is very high level. This isn't just a KubeVirt or even just modernization. This is all IT projects. But just to remind our audience here, close to 80% of large IT projects fail. So, we want to make sure that we are conscious of that. That's the odds are stacked against us. We need to make sure we're choosing solutions, strategies, and products that make sure that we fall into that 21% as opposed to the 79%. Additionally, these projects are often very long, right? So, and again, this isn't just transformation. This is just large IT projects. But in the context of replatforming, it makes sense that this would take a long time because for the challenges we listed earlier, upskilling, having to take maybe traditional physical infrastructure and kind of re-leveraging it for our new Kubernetes environment. So, 16 months being over a year in this day and age is a very long time. So we need to make sure we try to minimize the amount of time because we don't want to lose out to our competitors that maybe are also innovating quickly. It's essentially somewhat of a space race here. All the while, these projects are very expensive, $1.5 million average across, industries, across geos, but high level, this is the average cost of a large IT project. We want to make sure that we're getting our value for dollar, right? Again, going back to that, we don't want to be in that 79%. We want to be in that 21%. We really need to choose a solution and a platform that helps enable us to succeed. Wow, I vomited on those words, but I'll pause there, Michael.
Yeah, no, I think the data is quite telling, and I'm sure everyone on the call or in the audience has had some sort of failed project. Hopefully not as high as this, but I'm sure you've been close by to something like that. And I think this is the other big cost conundrum when it comes to the hypervisor Hunger Games, is that it's not just do you choose A or B, or do you take one pill or the other? It's the cost of resources, the cost of skills, the cost of the migration as well, is that you have to consider as part of those projects.
So yeah, and to that end, I guess we have this KubeVirt project, which again we've alluded to this multiple times, but running VMs on Kubernetes as well as containers within Kubernetes. This is a single platform that affords us that application centricity without having to sacrifice maybe our workloads that are best suited for virtual machines here. And of course, we're focusing on Red Hat. OpenShift virtualization, worth noting that OpenShift virtualization itself is not a product. It's really a feature of OpenShift. So if you have a physical Red Hat OpenShift cluster and the appropriate subscription or licensing is simply an operator to install in your cluster, it's a little bit different than taking a hypervisor ISO, installing that, and away you go. It is kind of Kubernetes or OpenShift first. And it's an easy lift then to add just that capability to then support VM workloads on your existing OpenShift cluster. So I want to take a moment to talk about migration. Very important here. Red Hat makes this much easier than having to do this in a homegrown way. And it's worth mentioning too, you can download vanilla Kubernetes, vanilla KubeVirt. You can roll your own However, speaking from experience, because I've actually been pecking at a project in my home lab actually recently where I'm doing just that. It's not easy. I'm currently, I left a container D was giving me issues, Cade, so I'll have to go try to figure out. It's a network issue, I know, but nonetheless, a great example of why maybe a commercialized or enterprise offering can help really de-risk that, and to that extent, also migration tooling as well, right? So there is a way to manually within Kubernetes, you can copy, a VMFS disk into like raw or QCOW, but it's very manual, it requires a lot of scripting. It's going to take a lot of time, may not be super successful. Why not just leverage a tool that an enterprise vendor has created for us to help ease that migration? Red Hat has done just that. They have their migration toolkit for virtualization. Essentially has a UI. You can point it at your traditional hypervisor. A number of them are supported. Obviously, VMware vSphere, but also Red Hat virtualization and OpenStack for those that are running on OpenStack. And also other OpenShift clusters. You can essentially point at that and then pull resources over. You can stage. You can essentially, choose what order you move VMs over. So it's all to say it's a very powerful tool, really useful. And if you need assistance, definitely, I think with my next slide, we'll hopefully highlight a lot of our key SI partners as well as Red Hat services can assist with. So if you're an enterprise that is looking to re-platform and need help migrating, definitely, these are key partners among others. We have plenty of professional services and SI partners. These are just some examples that we like to work with. Okay, so we've laid the land, we're coming up on time here, so I want to make sure that I'm not sucking all the wind in the room as I often do. Let's talk a little bit about Kasten, right? We've talked about OpenShift, we've talked a little bit about KubeVirt and Kubernetes, but why are we talking, at a Veeam event here about all of this? Obviously, Veeam as a company, as a data protection company, we have a product that can help support data protection of these workloads. So high level, why would I choose Veeam Kasten and Red Hat OpenShift? Number one, as mentioned before, data protection. We know we have data in these clusters, or at least referenced by these clusters, maybe outside even like a managed service. We want to be able to ensure that we back up that data maybe outside the cluster, but also our application components running on the cluster. So very important that we are protecting those workloads. And then throw in KubeVirt. Again, there is no more stateful workload than a VM. We want to make sure that we are protecting those or have a solution to protect that. Also, all the while, protecting against ransomware attacks. This was always a bit of kind of window dressing for Kasten for a long time until KubeVirt entered the picture, because ransomware attacks weren't a super big problem for containerized workloads. But then now with the introduction of KubeVirt and VMs, suddenly this has become very much an issue, right? With Windows VMs or, just generally speaking, more data being backed up. Threat actors know to attack the backup infrastructure. And once they have your backups, they essentially have you, right? So very important that we can isolate and leverage things like immutability to protect us against those ransomware attacks. Having a catalog to recover from. I know this sounds like for a lot of the kind of traditional Veemers or people that have been using Veeam for a long time, kind of taken for granted, but very important, often overlooked in Kubernetes is having a catalog of restore points, be able to go back to a point in time. Isn't always a given when we're looking at data protection solution for Kubernetes. I'll pick on Valero, an open source project. Very cool project, great for home labs or maybe test dev, but to have a catalog and go back and say, I want this point in time is very difficult in the Valero world relative to a full enterprise solution like Kasten. Obviously, application VM mobility. We're all about trying to be flexible, trying to support. And again, as an organization, Veeam has always been very open to cross-cloud, cross-platform, and we want to make sure that we're continuing that same ethos with our Kasten product, right? So if we want to move across clouds, maybe I'm running OpenShift on premises and then maybe in ROSA and AWS. So maybe storage is a little bit different or network. Kasten affords the ability to transform that data as we restore it to essentially allow us to recover our application in a running state. I think that's to simplify it, how I often articulate to customers is Kasten is the difference between, without Kasten doing a manual restore and getting a 500 error and having to bring things back up versus just performing a nice graceful failover using Kasten's disaster recovery or import policies and then having essentially your application come up and, a nice web UI, hopefully, that you've developed for your application.
The one thing I'd add to that as well, Matt, around application and VM mobility is the ability to leverage that data. It might not be you want to change anything in production. Production's working great, but I want to see what that workload looks like somewhere else. So you've got the ability to do that with that portability story that we have with Veeam across the board. Is I want to see what that VM looks like in Rosa, or I want to see what it looks like maybe back on prem, because a lot of people are making that move back as well. Like, so that leveraging data is another strong area, as well as application consistency, making sure that a database server is protected accordingly, not just the way in which like the power cable's just pulled out and hope for the best when it comes back up, that it doesn't ultimately blue screen or something bad like that. But yeah, ultimately these steps are hopefully familiar to anyone that is protecting virtual machines today across any of the hypervisors or public clouds.
Absolutely. And all the while, going back to that ransomware story, important that we can integrate with threat detection tooling, right? So Kasten itself is a cloud-native application. We are deployed as a Kubernetes application on top of OpenShift or whatever Kubernetes flavor you're running. And as a result, everything we do in Kasten can be observable and fed into observability tools. So really useful there. I think oftentimes among the kind of competitive landscape, we see a lot of bolt-on approaches, or again, kind of square peg round hole. Kasten in itself has been developed as a cloud-native Kubernetes application data protection solution out of the box. All the while, again, probably take it for granted by a lot of our existing Veeam customers, but having encryption and immutable backups is not a given in Kubernetes. So going back to our friends at Velero, I think there is now support for immutable backups in specific use cases. However, encryption is a bit of an issue in that it is a common key across the entire Velero project. So if Michael is running Velero in his lab and I'm running Velero in my lab, and we're sending to our respective S3 buckets, but I'm foolish and leave mine to be readable by the world, Michael can just take the key from his deployment and then unencrypt all of my backups. The kind of metaphor here is, or simile is, if I have a key and Michael has a key, but they're the same key to our house, are our doors really locked? Not really, right? So very important that we have encryption for our data, for our backup, and also be able to integrate with like key management solutions as well, right? So we need to make sure we stay one step ahead of our threat actors as much as possible. All right, all the while, and we're getting close to demo time, and you'll stop hearing from me as I suck up all the air in the room. OpenShift operators, very easy to install. This has actually even gotten easier. Shame on me for not updating this screenshot. There is now only one operator in the Red Hat operator marketplace. If you have an OpenShift cluster, all you have to do is within that OpenShift interface, navigate to operators, search for Veeam, search for Kasten. You'll see one option come up. It's a few clicks to deploy. You will then have Kasten essentially deployed for you, and automatically you have the option to automatically upgrade as well. So recall that I mentioned Kasten itself is a cloud-native application. We leverage the benefits of cloud-native velocity. So today we release every 2 weeks. So very, very nice there in terms of having new features roll out, as well as bug fixes, security fixes, what have you. The operator essentially can handle that for you and seamlessly upgrade your environment on your behalf. Worth mentioning too, we've got a number of optimizations built specifically for Red Hat technologies. This specific one is essentially our Ceph RBD or ODF, which is OpenShift Data Foundation, essentially optimizations. So here we are built in kind of behind the scenes. You won't notice this. There's nothing specific on the UI, but we've built in a lot of enhancements to ensure that we have the best possible performance in a Red Hat environment. So we're ensuring that we leverage the benefits that we can in the Ceph RBD CSI driver, as well as some a little bit secret sauce in the backend to make sure that we're always forever incremental. We're not having to send zeros every time. We're really trying to optimize our performance when it comes to underlying OpenShift storage. I picked on our friends at Velero. I've already told you the encryption key thing. That's the key thing I wanted to highlight here. Again, I know I love open source. I don't want to drag open source projects through the mud. It's a great project for a test dev or a home lab. If you're an enterprise, though, you probably are going to demand some more enterprise features here. So anything to add here, Michael, as I kind of shoot through these?
No, I have the same opinion. I think what the guys at Velero and other open source tools do from a simplicity point of view is great, and it pushes the awareness out there from a data protection, data resilience point of view within the platform. But yeah, I think like having that vendor behind it is a key ask when we're speaking to customers. How do we protect this, and also how do you have our back when bad things happen? is the key message here.
Absolutely. All right, as we round the around home plate here, getting close to home plate. As I mix my metaphors again, I should stay on the maritime thing. But anyways, this is a busy diagram, so I apologize. All to say that Kasten itself is cloud native. We are deployed as a cloud native application on top of OpenShift cluster. We essentially speak native cloud native, so we're using native Kubernetes APIs. We're not having to go in around the back door and do some unnatural things. And this means that we can do things like orchestration of deployment of Kasten, orchestration of automatic protection. We automatically recognize applications or namespaces as they're provisioned on the cluster. And we can send our backup data to object storage, NFS, and then more recently, VBR, or Veeam Backup and Replication, as long as they're block mode disks. So really useful there for our existing customers today that are using VBR but are looking to modernize to OpenShift virtualization. You can still leverage that existing Veeam infrastructure you have with Kasten. So you're not having to throw out those servers or buy a whole bunch of new kit. Worth mentioning, a great way to get started for those that like to tinker. My colleague Matt Bader created this fantastic validated pattern. Validatedpatterns.io is a great place to start when you're looking at OpenShift. Essentially gets you soup to nuts deployment of OpenShift, an OpenShift cluster with Kasten using, I think we're using HashiCorp Vault for key management. It's a great way to get familiar with it. I think our pattern deploys to AWS, but you could obviously leverage the components. It's open source. You can customize this for your own needs as well. Really great way to get started. If you're going to KubeCon, for anyone or coming up, I guess, in a couple months, definitely check out OpenShift Commons. There'll be a session on validated patterns. Very useful program, very interesting, good way to get started. All right, so let's go ahead and dive into a demo, Michael. I'm going to go ahead and probably hop off screen here and then talk through essentially how we can protect these VMs using Kasten. So here we see our Red Hat OpenShift cluster, which is deployed on 3 bare metal nodes in our lab data center. This should look pretty familiar if you're an existing Red Hat OpenShift user. If not, this is the OpenShift user interface. You can see here I could actually dive down and take a look at what pods are running on the cluster. So for natural containers, I can see pods across the entire cluster. Or if I want to dive in specifically to virtualization, I can just click the virtualization tab and actually click virtual machines, and this will give me an overview of all VMs running on this OpenShift cluster. Now, as Julia mentioned earlier, OpenShift virtualization is a feature of OpenShift. So it's essentially deployed as an operator on top of an existing OpenShift cluster. So it's worth mentioning again that this is not a type 1 hypervisor. This is running VM workloads in a pod or Kubernetes architecture. So before we hop over to the Veeam Kasten interface, I do want to highlight the operator hub just to show you how quick and easy it is to install Veeam Kasten there. So I'll navigate to the operator hub here. We'll let it load. And I'll type Veeam Kasten, and I can see the one offer here. So super easy to deploy. I can just click install, no need to purchase. That will deploy the actual operator onto the cluster, at which point I can then deploy what's called an operand or K10 operand, which allows me to actually deploy an instance of Kasten on the OpenShift cluster. So we've already done that, so let me go ahead and switch over just to show you what that looks like. So here is our Veeam Kasten dashboard. This user interface essentially is your end-all be-all for data protection when it comes to protecting OpenShift workloads. Again, whether those are applications or VMs, any associated CRDs, that is all able to be protected via this single interface. So diving in, hopefully it's pretty intuitive for you. You can see, on the top we've got 3 tiles. We've got our list of applications, our list of configured policies, and our data usage. I definitely want to highlight that you'll see here on the local cluster, we have a total of 542 gigs worth of snapshots. Whereas if you look at exported storage, that's only 426 megabits. Oh, I'm going to take that. Oh, there we go. Excuse me. So I do want to highlight here in the data usage tab that on the local cluster, we've got 542 gigs worth of local snapshots. But on our exported storage, which is where we're setting our backups, we're only consuming 426 megabits. I keep on saying it's megabytes. So I do want to take a moment to highlight this data usage tab. you'll see our total backup data is 542.4 gigs, which is consuming that space on our local cluster via snapshots. However, our exported storage is only 426 megabytes, which is a great proof point to show with our VM workloads, we're able to dedupe, compress, and send only incrementals to our off-cluster storage, which really helps us optimize costs as well as performance when we're both sending workloads off-site and then restoring from those backups. Diving in here, we've got the concept of applications, which typically correlates to OpenShift projects or Kubernetes namespaces. You see I've got a number of different workloads deployed here. I'll scroll down, you can see all my VM workloads are deployed in their own namespace. So VM01 is deployed in the VM01 namespace, VM02 is deployed in the VM02 namespace. This just makes it much simpler from a policy perspective to ensure that I can restore single VMs without having to deal with multiple VMs in a single namespace. Worth taking a look here at our restore point catalog. This is the very important thing about a data protection and backup solution, is having a catalog, seeing an actual ability to be able to restore to a specific point in time for a specific workload. I can filter on when the backup was created. I can filter on whether it's a snapshot or whether it was exported or imported from another cluster. So very useful here, makes it very easy to find the exact backup restore point that I want to restore from. Now, recently added in Veeam Kasten 8.0, we now have a virtual machine dashboard. Similar to OpenShift, this allows us to see all VMs that are deployed on the cluster and essentially configure or specify some configuration options for those VMs. So today, this dashboard is relatively limited in terms of actual operations that I can perform from this. I can either disable or enable OS freeze, which essentially allows Kasten to freeze or stun the disk when it's taken a snapshot, and obviously resume the disk when it's done. In the future, in the very near future, there will be more capabilities where we can actually do VM-based backup from this dashboard. So stay tuned for that and some very near-term releases. Now, diving over to my policies page, this is essentially where I can configure my backups and data protection, again, whether it's a cloud-native application, a VM, or a hybrid of both. So perhaps I have a VM and a cloud-native app all in the same namespace. I can protect that namespace in a single restore point. So before we go ahead and create a policy, I am going to kick off a policy that we've already pre-configured. We've got our VM02 backup. I'm going to go ahead and click Run Once. And I'm going to specify an expiration of this so we don't have to hold on to this restore point for all time. It'll be cleaned up here in a couple days, and I'll say continue there. And just to show you, if I go to the main dashboard, it's kicked off this policy job. We can see the actual run action being performed on the Kasten interface. So returning to policies, let's go ahead and set up a policy for a new VM that we've recently added to our cluster. So it's super simple. I can go ahead and click on Create Policy. I'll call this VM03 Backup. I'll go ahead and keep it as snapshot. Let's keep it as daily frequency. And then we've got our retention requirements here in terms of what we want to retain from a restore point perspective. For the demo, I'll go ahead and leave it as the default, but these are obviously configurable. I'll go ahead and specify an export location. So similar to a VBR backup target, in Kasten we call these Kasten location profiles. So it's very important that we actually send our backups off the cluster because, as we all know, snapshots are not backup. So I'm going to go ahead and select some S3 compatible storage. I also have the option to specify a different retention schedule if I wanted for those that are exported off the cluster, but I'll leave the default configured, which will use the local schedule defined above. Next, I'll specify the application in this case, which is a VM. I'm going to call it VM03. We'll specify that namespace. We're going to go ahead and capture all resources, but it's worth mentioning that I could either filter in or filter out specific resources in that namespace. So this is really useful. We see a lot of organizations that do this that maybe don't want to store secrets in their backups because they keep those secrets elsewhere, like in HashiCorp Vault or AWS customer managed keys. So a really powerful tool here to be able to filter which specific resources we want to include or exclude. So scrolling down, I'm going to go ahead and click, before I click Submit, let's go ahead and take a look. We've got our YAML equivalent here. So this is incredibly powerful and worth repeating. I know I mentioned before that Kasten itself is a cloud-native application, which means everything we do in the interface has equivalent YAML or Kubernetes native API commands in the back end. So this is a great example here where I've configured a policy. I can take this policy and essentially build it into my CI/CD pipelines and apply backup policy as code. So it's really useful to actually work as a template and then actually take our exported YAML and build that into our GitOps. So I'll go ahead and click Submit. I've got my new policy here, and let's go ahead and trigger it manually. So I'll click Run Once like I did before. I'll specify an expiration date. and we're off to the races. So that's running now as well. Let's see how our previous job is going. So it's nearly finished here. We've got our 1052 kickoff of our job. There we go. The local backup is completed. We're now going to see it exported off the cluster. And what we're doing in this case is actually sending this backup to Veeam Backup and Replication as a repository. So recall that I mentioned location profiles are where we send backup data when it's off the cluster. We now have the option since 8.0 to specify VBR as a location profile within Kasten, which means we can send our VM disks to VBR and then leverage the benefits that VBR has built in, like file level recovery, for our KubeVirt VMs. So we're going to let that run. Let's go ahead and switch over to our VBR server just to show you what that looks like. If you see, if I navigate to my just home screen within VBR, I go to Backups and Disk. Here's my VM02 backup, and I have the ability to quickly restore or do file level recovery. So let's go ahead and do file level recovery. We'll do Linux or other. All right, so let's go ahead and grab our latest backup here, our VM02 backup. So here I can use either a temporary helper appliance or I can specify a different host for my file level recovery for this Linux host. I'm actually going to use the same VM that I backed up from, and I'll show you why in a second. It really makes things much easier to restore specific files to my VM. So I'll navigate to VM02.Kasten local, and I've got some stored cluster credentials here. And what VBR is doing in the background is establishing an SSH session to this VM and essentially mounting the restore point disk back to the original VM. So really useful. I can actually launch the file browser, so I can actually see the VM's files here within the VBR interface, but I can also SSH back to this VM and actually explore the file system via native Linux tools and just copy the specific files I want that I want to recover for my VM. So you can see here's the file system. Maybe I navigate to home, I look in the Kasten user. You can see I've got a number of important files here. I could right click on one and just say restore to, or copy to for the local machine, or like I said before, I could SSH to this machine. I can see the actual mounted restore point disk on the virtual machine, and I can actually copy the files directly onto the machine itself. And then once I close this file browser, it actually unmount the disk and clean up, and I'll be back to business as usual. So a ton of other features to cover. In the interest of time, I'm not going to cover it in this demo, but worth mentioning, we do have transform sets, we do have blueprints, the ability to provide application consistent and logical backups, and of course we've got built-in reporting as well. So for more information, definitely check out veeam.com. We've got a number of interactive demos available there. And also if you've got an OpenShift cluster or Kubernetes cluster, you can try Kasten for free for up to 5 nodes. Excellent. Well, hopefully you guys learned something today. I had a lot of fun. It's always a pleasure to be with my friend and colleague, Michael Cade. End of the day, we want to make sure we're providing data protection for you, no matter what platform you're choosing, whether that's KubeVirt, whether that's a new hypervisor, whether it's your existing hypervisor, Veeam's got your back. We want to make sure we minimize that business downtime, make sure that we can help you recover in the event of disaster. And even in the case of maybe ransomware actors, we actually can negotiate it on your behalf. So very cool. I'm sure there's another session about our program there. But essentially want to just relay that we have your back as a data protection solution. Data protection is our business. We're not trying to sell storage. We're not trying to sell compute. We're here to protect your data. Very important to also make sure that we're not locking you in a specific cloud. So definitely be mindful when you're looking at data protection solutions for maybe Kubernetes or KubeVirt that you're not choosing a cloud specific one. There's that Hotel California. You can check in, you can never check out. We want to try to avoid that. Kasten obviously has your back in that regard. Reduce your risks and costs of your hybrid cloud journey. Remember that 79% projects fail at $1.5 million. You want to choose tooling and solution that ensures that you succeed. So, hopefully Kasten can be part of that for you. And of course, there's a Kasten operator that is fully featured, available within the Red Hat Operator Hub. Michael, I know I went through all of those really quickly. I probably stole some of your thunder, but anything to add before we wrap up?
No, I think you nailed it from a hypervisor Hunger Games. Having lots of conversations with prospects, customers, existing customers that are looking at the options that they have. Red Hat OpenShift keeps on coming up. SUSE Harvester keeps on coming up, as well as all of the Type 1 hypervisors that we mentioned up front. I think just go into that journey of understanding Kubernetes and Red Hat OpenShift as a platform. And it's not a new thing. This has been around. If you look at the KubeVirt project, it's been around for 5+ years now. It's quite mature. As is obviously storage on Kubernetes, which is where you're going to be storing those VMs. You saw the Ceph RBD integrations that we've worked on. There's lots more stuff that we've done, and we will continue to do from a Kasten engineering perspective to keep continuing that journey to protect that data is really our key point.
Awesome, thank you, Michael. So with that, to leave you with some resources, to learn more, definitely check out veeamkasten.dev. You can go to veeam.com to sign up for a free trial, or if you have an existing OpenShift cluster, easy enough to go to the operator hub to deploy. And thank you, everybody, for your time. I appreciate your patience, and hopefully you enjoy the rest of the event.